Hi everyone. Today we will be dealing with Indian Statistical Service Paper 1 2016. So we'll be discussing the previous year questions of Paper 1 for the examination ISS, Indian Statistical Service. So the first question is, x1 and x2 are independent Poisson variables such that p of x1 is equal to 2 is equal to p of x1 is equal to 1 and p of x2 is equal to 2 which is equal to p of x2 is equal to 3. What is the variance of x1 minus 2x2? So we can see that it is given that the given question is related to Poisson distribution, right? It follows Poisson distribution. And one more condition is given that the two variates, that is x1 and x2, they are independent. And in order to find the value of the parameter, two conditions are also given. So using these conditions, we need to find out the value of the parameters lambda 1 and lambda 2, which corresponds to lambda 1 corresponds to the first variate x1 and lambda 2 corresponds to the second variate x2, right? Then we need to find out the variance of the combined variate x1 minus 2x2. So let's find out the value of the parameter lambda 1 and lambda 2 separately. So first, using the first condition, we'll write down the first condition. That is p of x1 is equal to 2, which is equal to p of x1 is equal to 1. So we know that for a Poisson distribution, the probability density function is f of x is equal to e raised to minus lambda into lambda raised to x divided by x factorial, right? So we need to write the range of the variate also. Then only it will get completed. So is 0 less than or equal to lambda less than infinity, which means that the parameter lambda follows or takes only positive values. So using the first condition, we can find out the parameter value, lambda 1 value. So based on this condition, how can we expand it? So p of x1 is equal to 2. We need to give the value of x as x2. Then we can write it as e raised to minus lambda 1 into lambda 1 raised to 2 divided by 2 factorial, which is equal to e raised to minus lambda 1 into lambda 1 raised to 1 divided by 1 factorial. Why it is 1? Because x1 is given as 1. Here it is x1's value, it is given as 2. So we are just substituting the value in the probability density function. Okay, from this we can see that e raised to minus lambda 1. So this term and this terms will cancel out. So what is remaining? This lambda 1 and lambda 1 square is here. So only lambda 1 will be remaining. So lambda 1 divided by 2 factorial is nothing but 2, which is equal to 1. So from this, we'll get the value of lambda 1 as 2. Right. Then again, using the second condition, this condition will find out the value of lambda 2. So we can expand it as p of x2, we'll draw a line. P of x2 is equal to 2, which is equal to p of x2, which is equal to 3, right? So we can explain it like e raised to minus lambda 2 into lambda 2 raised to square divided by 2 factorial is equal to e raised to minus lambda 2 into lambda 2 cube. Here, why? Because x2 value is given as 3 divided by 3 factorial, right? So we can cancel these both terms. So what will be remaining? Lambda 2 square divided by 2 is equal to lambda 2 cube divided by 6. 3 factorial is 1 into 2 into 3, which is 6. Right. So we can cancel. Here lambda 2 square is there. Here lambda 2 cube is there. So only lambda will be remaining. And here 2 is there. Here it is 6. So it will be remaining 3. So we can write it as 1 is equal to lambda 2 divided by 3. Right. So we'll be getting lambda 2's value as 3. So lambda 2 is equal to 3. So we got the value of lambda 1 and lambda 2. Then we need to find out the variance of x1 minus 2x2. We know that variance of x1 minus 2x2. We can write it as, which is equal to variance of x1 plus 2 square into variance of x2. Here covariance terms will be 0. Why? Because in question it is already said that x1 and x2 are independent Poisson variables. So the covariance terms will be 0. Only variance terms exist. So here variance of x1 is nothing but for a Poisson distribution, if x follows Poisson distribution with the parameter lambda, then expected value of x is equal to lambda and variance of x is equal to lambda. For a Poisson distribution, mean is equal to variance. So this is an important property for a Poisson distribution. We know that for a Poisson distribution, mean and variance are equal. So by using this condition, we can find out the variance of x1 and variance of x2. Here lambda 1 is the mean or variance of first variate and lambda 2 is the mean or variance of the second variate. So here variance of x1 is nothing but 2 plus 2 square into variance of x2, which is nothing but lambda 2 into 3, right? So 2 plus 2 square is 4 into 3, which is equal to 40. So we'll get the answer, that is variance of x1 minus 2x2 will be 40. So here, in order to find, we know that for the variance property, variance of x1 minus a into variance of x1 minus bx2. If x1 and x2 are independent, it will be a square into variance of x1 plus b square into variance of x2. If it is not independent, it is given that it is not independent, what we need to add? We need to add the covariance term also. Covariance between x1 and x2, that also should be added. So here, since it is given as independent variate, only we need to add both the variance terms. So here we'll get the answer as 14. So option A is the right answer. So move on to the next second question, which is also related to a Poisson distribution. The question is, let x be a Poisson variate with the parameter lambda. So there is only a single variate which follows Poisson distribution with the parameter lambda, such that a condition is given. P of x is equal to 2, which is equal to 2 times P of x is equal to 4 plus 20 into P of x is equal to 6. What is the coefficient of skewness? So in case of a Poisson distribution, we know that in case of a Poisson distribution, the coefficient of skewness, we represent it with the letter beta 1, right? So beta 1 is equal to 1 by lambda. So we need to find out the value of beta 1. For that, first we need to calculate the value of lambda, that is the value of the parameter. So by using the given condition, we can calculate the value of the parameter lambda. So let's write the condition again. That is P of x is equal to 2, which is equal to 2 times P of x is equal to 4 plus 20 into P of x is equal to 6. So as we done in the previous question, let's expand using the conditions given. Like for that, we know that f of x is equal to e raised to minus lambda into lambda raised to x divided by x factorial, right? So we'll substitute x with the given values. we write it as e raised to minus lambda into lambda square divided by 2 factorial, which is equal to 2 into e raised to minus lambda into lambda raised to 4 divided by 4 factorial plus 20 into e raised to minus lambda into lambda raised to 6 divided by 6 factorial, right? So we'll cancel e raised to minus lambda terms. So it is existing on the left hand and the right hand side of the equal sign. So we'll cancel it out. And we can see that here one lambda square is there, here lambda raised to 4 is there, here lambda raised to 6 is there. So we can cancel lambda square terms from both sides, right? So it will become 1 by 2 factorial is nothing but 2, which is equal to 2 into, here what will remain if we cancel or divide it with the lambda square? Only lambda square will be remaining. Lambda square divided by 4 factorial is 1 into 2 into 3 into 4, right? Plus, again, 20 into, if we divide it with the lambda square, what will remain? Lambda raised to 4 divided by 1 into 2 into 3 into 4 into 5 into 6. Okay, so here you can see that 2 is present in both LHS and RHS. We can cancel. 2 is cancel, again 2 is cancel. So we can cancel 2, where it is 2, and 4, 5 is 20 cancel. So what is remaining? 1 is equal to lambda square by 3 into 2, 6, plus lambda raised to 4 divided by 18, right? 3 into 6, 18. So we can write it as 1 is equal to 3 lambda square plus lambda raised to 4 divided by 18. So lambda raised to 4 plus 3 lambda square, which is equal to 18, or lambda raised to 4. Sorry. Lambda raised to 4 plus 3 lambda square minus 18, which is equal to 0. See, this is now becomes the form of a quadratic equation. So we can solve. We know how to solve a quadratic equation. So we can write it as lambda square whole square plus 3 lambda square minus 18 is equal to 0. How we solve a quadratic equation? That is a square plus bx plus c is equal to 0. Then how we find out the value of x? X is equal to minus b plus or minus root of b square minus 4ac. Let's wipe it out. Okay. 4ac divided by 2a. So using the same equation, we'll solve this and find out the value of lambda. So what we get? So here instead of lambda, what we are taking? Lambda square. So here it is given as x. So for that, here the single term is lambda square. So we'll be, by solving this equation, using this, what we get, we'll get the value of lambda square, not lambda. Okay. So lambda square is equal to minus b. So it is minus 3 plus or minus root of b square. What is the value of b? It is 3. 3 square is 9. Minus 4 into a is nothing but 1. C is 18. Not 18, it is minus 18. Divided by 2 into 1. Right? So let's wipe it out, all this. So we'll get it as we'll get it as lambda square is equal to minus 3 plus or minus, this is 4 into 18, it is 72, right? 4 into 18, it is 72. 9 plus minus into minus, it will become plus. So 72 plus 9, it is 81. So square root of 81, it is 9 divided by 2. So it will become minus 3 plus 9 divided by 2, or minus 3 minus 9 divided by 2. Here you can see that here two values will be coming for lambda square. One will be positive and another will be negative. So can the value of lambda square be negative? No. Why? Because it is, first thing is, it is a square term. It can never be negative. And when we said about the probability density function, we have already explained that the value of lambda is positive, right? So this terms will not happen, right? So only this will exist. So we can write that lambda square is equal to 6 divided by 2, which is equal to 3. So lambda square is equal to 6 divided by 2, which is equal to 3. So we got the value of lambda square as lambda square is equal to 3. What is the coefficient of skewness? We explained earlier. That is beta 1 is equal to, it is written here. Beta 1 is equal to 1 by lambda. So lambda square is equal to 3. So lambda is equal to root 3. Can it be negative? No. Why? Because lambda cannot be, the value of lambda cannot be negative. It ranges from 0 to infinity. So we need to only consider the positive value, positive square root. So we got the value of lambda as lambda is equal to root 3. Then coefficient of skewness will be beta 1 is equal to 1 by lambda, which is equal to, we'll get the value of 1 by root 3. So the answer is 1 by root 3. Option A is the right answer. Okay, I hope these two questions are very clear for all of you. So we'll be coming with, in the upcoming videos, we'll be discussing more questions from the Indian Statistical Service examination. From questions asked in both paper 1 and paper 2 will be covered. And also we'll also try to cover the descriptive type questions asked in the previous years also. So till then, bye. Take care.